Hi, my name is Merritt Harlan. I'm with the United States Geological Survey in the Hydrologic Remote Sensing Branch. Today I'm really excited to be talking about hydrology from space, introducing the Surface Water and Ocean Topography, or SWOT satellite. This talk is part of the Hacking Limnology 2024 4th Joint Virtual Summit and Workshop. Some of the information I'm presenting is preliminary and subject to revision. First, I'll provide some background on the SWOT satellite. Then I'll discuss SWOT data formats, data accuracy, as well as data availability timeline. Finally, I'll highlight some of the exciting SWOT science applications. The SWOT satellite uses advanced wide swath technology to measure ocean and surface water topography. These high-resolution products can then be used to support societal need. The SWOT satellite successfully launched in December of 2022 after many decades of planning and progress. The satellite represents a collaboration between the United States, French, Canadian, and United Kingdom space agencies. SWOT uses a Ka-band radar interferometer to measure global ocean surface topography and land surface water extents and elevation with great accuracy. Here we have a depiction of the SWOT payload, which includes the Ka-band radar interferometers on either side, as well as a down-looking nadir altimeter. What's unique about SWOT is that we have these wide swath interferometers that help us aggregate different returns of water elevation across wide areas, enabling higher resolution and accuracy than previously found in other satellites. Today's talk will mostly feature hydrology applications, but I did want to highlight the many exciting oceanography and coastal applications as well. On the left, we have a depiction of SWOT sea surface height data, and on the right, the previous global standard. As we can see, SWOT is providing much higher resolution data, which allows us to start to look at sub-mesoscale structures of ocean circulation. On the SWOT hydrology side, SWOT measures both lake and river extent as well as elevation over broad spatial scales. This figure, borrowed from Fu et al. 2024, depicts SWOT water surface elevations in the Yukon-Kuskokwim Delta in Alaska. From this one day of SWOT data on June 18th, we see water level across thousands of water bodies, and in panels B and C, we can start to make out pretty small lake features, which is exciting to see from SWOT. SWOT data comes in varying formats, which we will discuss more in the data access workshop. Two level 2 products for hydrology I wanted to highlight are the Pixel Cloud and Raster products. These two data sets are generated from SWOT backscatter values as shown here in the sigma naught graph. We can see that lake and river features have higher returns of sigma naught backscatter, and we can use those returns to mask out where water features are and estimate their water surface elevation and water surface area from that data. SWOT data also comes in a vector format. Here we see river reaches, for example, the Colorado River near Austin, Texas here. Reaches are broken into river segments around 10 kilometers of length, and these reaches can also be further broken down into river nodes, or points along a center line spaced about 200 meters apart. Both the reach and node level data have water surface elevation as well as river width associated with each point, and at the reach scale, we can also calculate river slope as well as derived discharge. For the lake side, similarly to rivers, we have polygon data. In this case, lakes are represented by not lines or nodes, but instead fully explicit polygons representing the water surface elevation and area of a given lake. These two data, water surface elevation and area, can be used to derive storage change as well. I wanted to briefly highlight some of the SWOT quality challenges or features to look out for when using some of the earlier SWOT data products that have not been fully validated. One challenge with radar data is for SWOT, we expect the lake and river products to show up as bright on a backscatter image. In some cases, due to precipitation or the spectral signature of a river, for example, these features might instead show up as dark, and we call this phenomenon dark water. There's a flag in the data products to indicate if different data might be impacted by dark water. Another challenge is something called the phase unwrapping issue, which can occur when certain pixels might be misaligned in the product, and so this section of the river has been shifted over to the left, and further calibration should address these challenges. Another phenomenon we might see is bright agricultural fields or other factors such as ice or snow showing up bright on the backscatter. And so in this case, we have inundated fields close to the river channel that are classified as water in this case. This challenge in some ways is a nice thing. If users are interested in looking at, for example, inundated vegetation, they might be able to use SWOT in this case to get at some of the elevation of other types of water bodies as well. Another challenge is river geolocation, where some of the prior river or lake databases might not correctly have the river center line down. And so in this case, we see that the prior river center line in blue is shifted to the right of the true center line. Nevertheless, despite some of these challenges, we are seeing some pretty exciting accuracy and expecting some great accuracy from these SWOT data products. For water surface elevation, we expect the water levels to be accurate within about 10 centimeters for large water bodies and within 25 centimeters for 250 meters squared to 1 kilometer squared range. For water extent, we expect it to be accurate within about 15% for these large areas, and lake storage change is estimated to be accurate within 5 to 20%, depending on the water body size as well. River slope we expect to be accurate within 1.7 centimeters per kilometer across a 10-kilometer reach. And for river discharge, we expect around 30% for large rivers, but this river discharge is still very much in progress as we're better understanding the accuracy of SWOT. In terms of the data timeline for availability, so SWOT launched in December of 2022. In November of 2023, SWOT beta pre-validated data was released publicly for the hydrology level 2 data, that is. And in March of 2024, the same hydrology SWOT pre-validated data was released publicly. In fall of 2024, NASA is implementing some additional fixes, quality flags, and river area improvements. And the next bulk reprocessing is expected to occur sometime in 2025, which will introduce calibration as well as some improvements to lake and rivers. Beyond this time, we also expect discharged data from SWOT to become available, as well as storage change and potentially the generation of floodplain DEMs as well. Moving into the exciting science that might be possible with SWOT, some questions that SWOT is really able to address now is how do water levels change downstream? Before, if we had, say, a gauge on a river, often that's just a point location and it can be hard to know exactly what's happening upstream or downstream of a gauge unless they're very closely spaced. As SWOT will observe full river profiles, this provides some exciting possibilities. Another question is looking at lake and reservoir storage change at a global scale, as well as water storage change in rivers globally. We can also relate rivers and lake levels as well as other parts of the hydrologic cycle to see how they correspond spatially and temporally through SWOT. For example, we can look at SWOT longitudinal profiles. Here we're depicting SWOT water height as a function of reach distance going upstream. Here we're looking at the Willamette River south of Corvallis across a couple of months of SWOT data between February and July of this year. Here we can plot spatially how SWOT water level might change over time and over distance, which is exciting to see. SWOT can also be used to monitor lake and reservoirs. SWOT uses multiple measurements of water body extent and elevation to derive lake storage change over time, which is depicted here, where if we can approximate the hypsometric curve, we can estimate volume change for a given water body. This slide, courtesy of Jida Wang at University of Illinois, takes a first look at global lake storage changes from SWOT between January and May 2024. Lakes are split up into reservoirs, which include any man-made controlled water body, versus natural lakes. Here we can see that although reservoirs account for 10% of global lakes by count, they approximate 56% of seasonal water storage variation in this preliminary study. SWOT is also one of the first satellites that we can really look at stream flow from space, which is very exciting. SWOT will measure changes in water level along with simultaneous changes in river width and river slope. What SWOT won't observe is the cross-sectional area or absolute depth of the channel, nor bed roughness or velocity. However, we can use flow law equations to relate the changes in water level, river width, and river slope to overall discharge. Here we see an application of SWOT to detect floods in Brazil. On the left, we have a depiction of SWOT, and in light blue is the water extent, and then in red and yellow colors, we can see the relative elevation difference between the water bodies from flooding to prior to flooding period. On April 14th, prior to the flood, we can see the dam's regulation in place with a much higher water level compared to downstream. And then on May 6th, during the flood event, we see a much larger water extent and similar water elevation values all throughout the image. And that's all I had for this brief intro, but please feel free to reach out with any questions you might have or collaboration ideas. My name, again, is Merritt Harlan. You can find me at that email address. I also wanted to give a shout out and highlight Cassie Nichols, who will be giving a data access workshop surrounding SWOT and has a wealth of great resources out there about SWOT. Some of those resources in particular include the PODAC cookbook site, which can be linked there and includes SWOT tutorials, webinars, and a lot more information. There's also a very detailed SWOT user handbook, which I recommend checking out if you would like to get into more in-depth information, say about SWOT quality flagging or the algorithms themselves. Thanks again.